If z equals to p raised to n into e raised to minus r square upon 4p, find the value of n so that the relation 1 upon r square into dou upon dou r of r square dou z by dou r equals to dou z by dou p is true for all p such that p greater than 0. In this question, we need to find the value of n and we have to use the relation, this relation given z equals to p raised to n into e raised to minus r square upon 4p, differentiating partially both sides with respect to r. Therefore, dou z by dou r equals to of p raised to n e raised to minus r square upon 4p. Taking p raised to n outside, dou upon dou r e raised to minus r square upon 4p. Since we are differentiating partially with respect to r, therefore p raised to n has no role, therefore we had taken outside p raised to n. Now differentiation of e raised to is nothing but e raised to minus r square upon 4p into dou upon dou r of minus r square upon 4p equals to p raised to n e raised to minus r square upon 4p into minus 2r upon 4p. This is equals to p raised to n upon p upon 2p, and here is a minus r e raised to minus r square upon 4p. This is equals to p raised to n minus 1 upon 2, n minus is taken outside, r e raised to minus r square upon 4p. This is nothing but dou z by dou r. So we are having dou z by dou r equals to this much given by the equation 1. Now given relation is 1 upon r square dou upon dou r square dou z by dou r equals to dou z by dou p. We need to find the value of n. So what I am going to do, in previous calculation I am having dou z by dou r, so I am going to put the value of dou z by dou r here. Now I am going to take LHS. LHS equals to 1 upon r square dou upon dou r square dou z by dou r, which is equals to, first I will operate LHS, then RHS, then compare them. Here is the r square. Value of dou z by dou r is nothing but minus p raised to n minus 1 upon 2 r e raised to minus r square upon 4p. This is equals to 1 upon r square into minus p raised to n minus 1 upon 2, that is taken outside because we are doing partially with respect to r, therefore p has to be taken outside. Now here it is r cube and e raised to minus r square upon 4p, and there are the two parts, one is the r cube, another is the e raised to minus r square upon 4p. Therefore we require to do the differentiation partially with respect to r by using the product rule, which is equals to r cube into partial derivative of e raised to minus r square upon 4p plus e raised to minus r square upon 4p into partial derivative of r cube minus 1 upon r square p raised to n minus 1 upon 2 r cube into e raised to minus r square upon 4p into minus 2r upon 4p plus e raised to minus r square upon 4p into 3r square equals to minus 1 upon r square p raised to n minus 1 upon 2. Here 2 ones are 2 twos are cut down, minus r raised to 4 upon 2p into e raised to minus r square upon 4p plus 3r square into e raised to minus r square upon 4p. Now I am going to take common e raised to minus r square upon 4p because it is present at the both the places. That is equals to minus 1 upon r square into p raised to n minus 1 upon 2 into e raised to minus r square upon 4p common. What is left now? R raised to 4. Here is r raised to 4. So that can be written r square into r square upon 2p plus 3r square. Now again taking r square common, so we have left with minus r square upon 2p plus 3 r square get cancelled. This can be written as p raised to n minus 1 into e raised to minus r square upon 4p into minus 1 by 2 and minus r square upon 2p plus 3. Now this minus 1 by 2 will be taken inside. So we get minus r square upon 4p plus and minus 3 by 2. Now multiplying and dividing by p here. Therefore LHS equals to p raised to n minus 1 e raised to minus r square upon 4p and 1 upon p is taken common. I get here r square upon 4 minus 3p upon 2. This is equals to p raised to n minus 1 upon p into e raised to minus r square upon 4p and r square upon 4 minus 3p by 2, which is equals to p raised to n minus 2 e raised to minus r square upon 4p and r square upon 4 minus 3p upon 2. Let us call it as a equation number 2. This is equals to LHS. Now what is RHS? RHS is nothing but dou z by dou p. So we will be finding out now dou z by dou p. Now RHS equals to dou z by dou p, where z equals to p raised to n into e raised to minus r square upon 4p. Dou z by dou p. Now here to apply the product rule, p raised to n into partial derivative of e raised to minus r square upon 4p with respect to p plus e raised to minus r square upon 4p into partial derivative of p raised to n with respect to p equals to p raised to n into e raised to minus r square upon 4p into partial derivative of minus r square upon 4p with respect to p. plus e raised to minus r square upon 4p. Partial derivative of p raised to n is nothing but np raised to n minus 1. This is equals to p raised to n e raised to minus r square upon 4p into minus r square upon 4 into partial derivative of 1 upon p nothing but minus 1 upon p square plus e raised to minus r square upon 4p into n p raised to n minus 1. Now taking e raised to minus r square upon 4p common, so we are left with p raised to n into plus r square upon p square plus n p raised to n minus 1. Now here multiplying and dividing by p, which is equals to e raised to minus r square upon 4p p raised to n minus 2 into r square plus n p raised to n minus 2 into p. By mistake I have not written 4, now writing here upon 4 upon 4. Now I am going to take again e raised to minus r square upon 4p p raised to n minus 2 common. So I do have r square upon 4 plus np. This is nothing but RHS, result of dh by dou h by dou p equals to, call it as a equation number 3. Now comparing LHS and RHS, the result of LHS was equation 2 and result of equation RHS was equation number 3. Now we are going to compare LHS and RHS because our aim is to find the value of n. So LHS nothing but this much and the RHS we are having. Now I am going to compare LHS and RHS. After comparing LHS RHS, I have cancelled the similar terms. Then what is left? R square upon 4 minus 3p by 2 equals to r square upon 4 plus np. Cancelling r square upon 4 both sides. So minus 3p by 2 equals to np, and p and p also get cancelled both sides. Therefore I get n equals to minus 3 by 2. This is required solution. I hope you understood these calculations. I tried my level best to present this problem in simplified manner. If you like the video, if you like the presentation, I request you to share with your friends so that the needy student will get benefited. I will come with another video. Till then, bye bye. See you. Wish you all the best.